Hello everybody. This video will introduce the last new concept of Chapter 5 before we review and then test later in the week. So we're going to start by going back to an old friend, the Pythagorean theorem, and that old friend is going to help us understand this new idea, this last new idea. And so hopefully you remember Pythagorean theorem in some form like this. And also that you remember it has to do with right triangles. And so we're going to look at this given triangle, and then first of all let's label the sides. So this side length being the longest side across from the right angle is called the hypotenuse, as we've talked about in class a little bit. And the two sides that are not the hypotenuse are known as legs of a right triangle. And so just to make sure you understand where certain sides fit into the Pythagorean theorem, let's make sure we use this triangle on the right to write out an equation that would relate the side lengths. So x is a leg, so we take x and square it. Z is a leg, so we take the length z and square it. And y is the hypotenuse. So the legs squared and added together equals the hypotenuse squared. All right, so remembering that as a hint for what's to come. So we're given two triangles here, and let's realize that they both have right angles, so those are congruent. They both have a side length of 12, and they both have a hypotenuse of 13. And so be careful in this one. It is going to be that it's side-side angle. So up until now, we don't have enough information to prove that these are congruent, so we would say no to part B. But let's do a little digging with the Pythagorean theorem and see what happens. So I'm going to call this chunk A, that side length, and just set up a Pythagorean theorem here. A squared plus 12 squared equals 13 squared. And that gives us A squared plus 144 equals 169. And then solving further, we get A squared equals 25, and so A would equal 5. Okay, so with that work, we can find out that this length from B to C in my diagram is equal to 5. And then if we try to do it on the other triangle, where let's call this side length X, hopefully you would see that you should get the same length, but I'll show the work anyway, and I'll use just copy this work that I already did and change everything that was an X, or sorry, that was an A, to an X. So X squared plus 12 equals 13 squared, and all the way down to where X equals 5. So awesome. We now know that these two sides are equal to 5. So actually, now it says, now do we have enough information to prove that they're congruent? And the answer would be yes, because of side, side, side. Because the Pythagorean theorem got us the third side. So what that really means is SSA, this thing that we thought up until now wouldn't work, only works if that A is a right angle. So in the case that that's a right angle, then SSA does actually work. So we give it a different name, and that's what this section is all about. It's a different name for that scenario. But if your angle is a right angle and you have two of the sides, then you know enough to prove triangles are congruent. All right, so let's draw in down below and fill in some general summary ideas down here. So we're given right triangles. Let's give ourselves the longer leg, this one here, and I'll give myself the hypotenuse. So it's what looks like angle side side from before, but now we can see it as we're given right angles, so a pair of right angles are congruent. And then we're given a pair of hypotenuse lengths are congruent, and we're given a pair of legs are congruent. Okay? So instead of calling this angle side side, because that one we know doesn't work, we instead call this RHL, using the three letters that begin these three words. So we can now use that as a justification in our proofs. So RHL becomes a fifth and final. Here's the fifth way we can prove triangles congruent. That's the last one we'll have. And let me clarify something, and that is, I'll do a different color here. Remember the three that we had that involved angles. So all of these justifications involve getting congruent angles. in those cases, whenever we had an A, that A represented a pair of congruent angles. Okay, a pair of congruent angles. You know that very well. You've done a bunch of proofs with it. But when we go back here to R, so when we're going to use R for RHL, the R in RHL is actually representing a pair of right angles. So we only need to tell the jury that we have right angles. We don't need to tell the jury that they're congruent. Okay? So it's right angles, then a pair of hypotenuse lengths, then a pair of legs. Okay? So the new one, RHL, I'll put a box around it. There is the fifth and final. You might want to add it to your theorem sheet. The fifth and final way to justify triangles congruent. So let's actually use it. Okay? So let's see what I'm given here. I'm going to mark my perpendiculars. I'm given this one perpendicular here and here. And then I'm given this perpendicular down here. And I'm given AB congruent to DC. So that's all I'm given, but I understand that this is a right angle based on perpendicular. And let's see what we're trying to prove. We're trying to prove, let me go with a blue highlighter, DBA. So this triangle, D to B to A, oops, D to B to A, is congruent to this triangle, which is its buddy, B to D to C. So noticing that D is the smallest angle in its triangle and B is the smallest angle in this other triangle, so this would go BDC in correspondence, and they share a side. So there's our reflexive side, which also happens to be the hypotenuse. So let's find what we can. It looks like we're first given a pair of legs. So I have L for RHL. And then the next thing I can state pretty obviously is that DB must be congruent to itself, reflexive. And then we can state that we have right angles, so A and C are right angles. We don't need them to be congruent, we need them to be right angles, and that's because perpendicular implies right angles. Okay, so there's our R, and here's our H, and so we have everything we need for RHL. So previously we would not have been able to prove these triangles congruent because it's angle side side. And angle side side hasn't worked, but if there's a right angle, it does work, and instead of calling it that, we call it RHL. Okay, so take a minute, hopefully that makes some sense. Pair of right angles, hypotenuse lengths congruent, and a leg congruent to another leg, the corresponding legs congruent. All right, so that's one proof. I guess I would like you to try number 4 on your own. I think it's doable. I hope it's doable. And the confusing thing will be which triangles do you want to get congruent? And so maybe focus on the ones that you are given an altitude in, and hopefully you can figure it out from there. But just like in number 3, there's going to be a shared side in number 4. So I'll put hints on Canvas, but hopefully you can figure that out. Then let's do number 5. I'll do number 5 on the video, and then you can try 6 on your own. Okay, so this one involves bisecting. I thought it was a little more challenging, so probably worth doing together or on the video. So I'm given these are perpendicular. And then, so that implies that I have a bunch of right angles. Right there are right angles. And then I have SE congruent to IR. And then I have, what else do I have? I have SR cuts in half IE. So I'm going to be able to say these triple ticks are congruent to each other. And so let's see, do I see right triangles that I can get? Here's a right triangle down below, this tiny one. And here's a right triangle up above that I can get congruent. Okay, so let's write this in. We can use an arrow for the givens to save us some time. And then let's see what we can state. We can definitely state that these angles here, 1 and 2, are right angles because of perpendicular. So angles 1 and 2 are right angles, and that's because perpendicular implies right. Oops. And then what else can we get? We can get IB and EB are congruent. So IB congruent to EB. And that's because bisect tells us that they're congruent. So bisect implies congruent segs. Oops. Okay, let's see what we have now. I'm going to take a second to figure out what we have. We have a right angle. We have leg, so this is a leg of that triangle, and we were given the hypotenuse. So we can now state the triangles are congruent. So let's name these triangles. So I'm going to say I to B to R, that's the bottom triangle, is congruent to E corresponds with I. So this is EBS. And this is by RHL. Right angles, hypotenuse, and leg. Sweet. So why is that helpful? We are trying to prove, I forgot to even think about what we're trying to prove. We're trying to prove that this question mark is congruent to this question mark, because that would tell us that IE bisects SR. Yeah, okay. So then from there we can say we have congruent chunks. So SB is congruent to RB. And that's because congruent triangles imply corresponding parts congruent. Okay, and step 6, now we can say that IE must be bisecting or cutting in half SR. IE bisects SR because congruent segments, which we just stated, implies bisect. Okay, let me check to make sure this makes some sense. I got RHL to get triangles congruent, corresponding parts, and then finally bisect. Yep, that looks good. All right, so I would leave 6 for you to try as well. I'll leave hints on Canvas. This is one of these that's tricky with the overlapping triangles that are kind of hard to see. So look at hints on Canvas as you need to, or ask me if you want to meet with me during office hours. We can do that too. Your goal would be to finish numbers 4 and 6. All right, have a good day.